Hey everybody, so in this lesson we are going to learn a new factoring skill, and we're going to learn how to factor polynomials that have 4 terms in them, just like these 3 polynomials that you see on your screen right now. Now, is this strategy going to work for every polynomial with 4 terms? No. Will it work for some polynomials with 4 terms? Absolutely. And it's called factoring by grouping, and we'll learn why very soon. But before we go ahead and factor, I think it's going to be really helpful for us. In the upper left-hand corner, I had a simple polynomial multiplication problem. And what I want us to do is start by doing this problem really thoroughly, because it's going to shed a lot of light on how we factor these polynomials. Because the process is actually going to be exactly the reverse of what we do when we multiply these two. So let's do it. Now, I think if we were going to multiply 2x squared plus 5 times the quantity of x minus 4, the first thing I would do is I would multiply 2x squared by x minus 4. And then I'd multiply 5 by x minus 4. And while sometimes we kind of just do that in our head, we know we have 4 steps of multiplication, I want to take some time to explicitly write that out. So I think if we were to multiply those polynomials, what we'd first do is we would take 2x squared, and we would multiply that by the quantity of x minus 4. And then I think we would add 5 times the quantity of x minus 4. Not so bad. We just took this term and distributed it to every term in this polynomial, and this term, and distributed it to every polynomial, every term in this polynomial, excuse me. Now let's go ahead and multiply this out. I'm going to do something a little weird here. I'm going to stick a set of parentheses around what we get when we multiply these. We probably wouldn't do that normally, but it'll help us a lot for this lesson. So 2x squared times x is going to give us 2x to the third power. 2x squared times negative 4 will give us negative 8x squared. And I'm just going to plop a set of parentheses around that, even though we normally wouldn't. 5 times x is going to give us 5x. And 5 times negative 4 will give us negative 20. And I'm going to plop a set of parentheses around this as well. Now, of course, if we were multiplying, we'd want to collect any like terms. I actually don't see any like terms, so I think we can write our final product in this case as just 2x to the third power minus 8x squared plus 5x minus 20. And so now you see our product is a polynomial with 4 terms, and this is exactly the type of polynomial that we're going to try to factor in this lesson. And how are we going to do it? Well, our general strategy is going to be, of course, put it into standard form, look for any common factors. Okay, we're done with that. If it's a polynomial with 4 terms, then any of our strategies we've learned before aren't going to apply. And so what we're going to do is we're just going to take the first 2 terms and we're going to group them together. We're going to stick a set of parentheses around them. And we're going to take our second 2 terms and we are going to also group them together by putting a set of parentheses around them. Okay, then what? Then we look for a common factor from these first 2 terms. So if I look at 2x to the third power minus 8x squared, I think a common factor is 2x squared. And if you were to factor out a 2x squared from these 2 terms, you would get 2x squared times the quantity of x minus 4. And if you were to look at these 2 terms in the other grouping, they have a common factor of 5. And if we were to factor out a 5 from here, we'd get 5 times the quantity of x minus 4. And what's really cool is if you look at this step right here, I think I've got 2x squared, x minus 4s, and 5 more x minus 4s, for a grand total of 2x squared plus 5, x minus 4s. This step to this step, going from here to here, is definitely probably the most confusing of this entire lesson. But with some practice, I hope that it'll begin to make more and more sense. We're kind of taking these common factors. We've got a common factor of 2x squared and a common factor of 5. And we're kind of doing some reverse distribution here and writing this statement as a product of these 2 polynomials. So let's actually get to some examples. So here we go. 6m to the third plus 9m squared minus 10m minus 15. All right. There are no common factors. It's in standard form. It's got 4 terms in it, so we're thinking maybe we can factor this by grouping. So let's go ahead and group those first 2 terms together. So we've got 6m to the third power plus 9m squared. And now let's group those second 2 terms together. Now it's really important that we're really careful about not doing any shortcuts, and we got to be very careful about our signs. So I'm actually going to put plus negative 10m minus 15. I want to give a heads up. A lot of students have the tendency to just, in this line right here, put some parentheses there, put some parentheses there, and I really don't like that shortcut because sometimes you end up writing a statement that just isn't true. So please, please, please write this on a new line and separate your two sets of parentheses with the addition that should be there. If there was no addition sign right here, if there was nothing at all, it would look like this is multiplication, which we absolutely know it isn't. Okay, so let's look at this first grouping. Is there a common factor between 6m to the third and 9m squared? I think there is. I think they have a common factor of 3m squared. So I think we could write that first grouping as 3m squared times the quantity of 2m plus 3. Let's look at the second grouping. Is there a common factor here? Yes, I think there is a common factor of 5, or better yet, negative 5. So I'm going to factor out a negative 5 from these two. And I'm going to write this as, you can either write this as plus negative 5 times this whole quantity, but I'm going to go ahead and just write it as minus 5 times the quantity of 2m plus 3. Awesome. And now check it out. I see that we've got 3m squared times 2m plus 3 minus 5 times 2m plus 3. And you know how I think we could get to this step? I'm kind of thinking in forward and reverse here. I think that if our original multiplication problem were 3m squared minus 5 times 2m plus 3, then if we were to carry this out, this is exactly what we would do. We would distribute 3m squared times all of this and negative 5 times all of that. And so right here is the final factorization of this polynomial right here. And if you wanted to check this out, you would simply multiply these together. And you know how you do that? This is your next step, this would be your next step, and this would be your final product. So you can quickly look over to check and make sure that you have factored correctly. Awesome. So I hope that this is beginning to make more sense, and maybe you can start anticipating how to take care of some of these as I make my way through. So in this example right here, we're in standard form, no common factors, 4 terms. Let's try to factor by grouping. So our first grouping is just going to be 8b to the third plus 2b squared. And our second grouping is going to be negative 12b minus 3. All right. Now, in our first grouping, do I see a common factor? I do. I see a common factor of 2b to the second power. So let's write this as 2b to the second power times the quantity of 4b plus 1. And in our second grouping, I see that we've got a common factor of 3. So better yet, let us factor out a negative 3. All right, so let's write this as plus negative 3 times the quantity of 4b plus 1. All right, I'm feeling good about it. I see this 4b plus 1 here. I see a 4b plus 1 there. And so I think that the final step of our factorization here is going to be 2b squared minus 3 times the quantity of 4b plus 1. And this last step is definitely the most confusing. And what I would say is, remember that factoring a polynomial means find the two other polynomials that multiply to give it. So we're kind of doing multiplication in reverse when we go this way. Oops. And so think when you're going from this second to last step to the last step is, well, what would this multiplication problem have had to be if this would be your next step? And so that's the way I think about it. And one other thing, these two terms right here, this 4b plus 1 and 4b plus 1, they've got to be identical for this to work. If you ever get to the point that these two are not identical, then we cannot continue to factor. All right, here we go. A couple more examples. I see that we've got a standard form, no common factors, 4 terms. Let's go ahead and try grouping. So I'm going to group together the 2x to the third power minus 10x squared, and we are going to group together the x minus 5. All right, so now in that first grouping, looking for common factors, I think this guy has a common factor of 2x squared. So 2x squared times the quantity of x minus 5. And I'm looking at this second grouping, and I don't see any common factors at all. So you can either just rewrite the x minus 5, but what I like to do is I like to write this as 1 times x minus 5. It really helps me visually to put that 1 there, because then I think, oh, the final step of this factorization is going to be 2x squared plus 1 times the quantity of x minus 5. So even if there isn't actually a common factor, and 1 is your greatest common factor, that's okay. And I like to write that 1 there because it really helps me out. All right, guys, just 4 more examples. So looking at this first example in the upper left, 6g to the third plus 4g squared minus 6g minus 4. It's already in standard form, but I do notice that these 4 terms do seem to have a common factor, and that greatest common factor appears to be 2. So remember, we always got to look for common factors after we put our polynomial in standard form. So first things first, let's factor out that 2. And we're going to rewrite this as 2 times the quantity of 3g to the third plus 2g squared minus 3g minus 2. Now, common factors are a bit of a pain in the butt with this specific type of factoring of these 4-term polynomials. So what's going to happen is we're going to carry this 2 down every single step. So now we've got this polynomial right here that we're going to try to factor by grouping, this guy right in the parentheses. So we're going to group these first 2 terms together. So we're going to rewrite that as, let's see, 3g to the third plus 2g squared in its grouping. And then we're going to have negative 3g minus 2 in its grouping. Now, let's carry down this 2, this common factor from before. But however, if we were to just write this, it appears that this 2 is being multiplied only by this first grouping when it's really supposed to be multiplied by the entire rest of the polynomial. So to make that very clear to our readers, we actually need to put in either a second set of parentheses, or I like to put in a set of brackets, just so they know, oh yes, this 2 is being multiplied by everything. Okay, let's proceed. From this first grouping, I think we have a common factor of g squared. All right, so we've got g squared times the quantity of 3g plus 2. And from the second grouping, I think we have a common factor of, well, if I left it by itself and just left this as negative 3g minus 2 and had a 1 out in front, well, this wouldn't be the same as negative 3g minus 2. So let's factor out a negative 1 here. Because if I factor out a negative 1, let's see, minus 1 times the quantity of, well, 3g plus 2. Remember, it's super important that in this second to last step, these 2 are exactly the same. We need a 3g plus 2 and another exactly the same 3g plus 2. If these were different, we would not be able to proceed. Now let's carry down our common factor from before. Here's that 2. And it's a good idea for us to stick in these brackets to let the reader know it's being multiplied by everything. Okay, so now in here, we're ready to do that final step of factorization. And so we can write this as g squared minus 1 times the quantity of 3g plus 2. Awesome. And now we can carry down that common factor of 2. And voila. No need for any brackets anymore because this is all multiplication and it's all groovy. And so, that was tough, but we finished. Actually, we didn't. What? Check it out. One of our terms here, or rather one of our groupings is g squared minus 1, and this is a difference of squares. So we can factor even further. And in general, whenever we're factoring these polynomials, we got to keep on factoring until we can't factor anymore. And this factors as g plus 1 times g minus 1. So our real final factorization is 2 times the quantity of g plus 1 times g minus 1 times 3g plus 2. Yowza! Hey, I know that was a tough factorization, but this is big boy and big girl math, so sometimes we're going to have tough factorizations. So, woo! Now, I know that taking care of this common factor throughout each step was pretty laborious and took a whole lot of attention to detail with all these parentheses and brackets and whatnot. So another strategy that I sometimes use is once you factor out that common factor, and once you get to this step, I quite literally take this entire polynomial, I kind of write it somewhere else on my page, take care of factoring it elsewhere, and then in that final step, bring it on back here, and then of course tack on that common factor from before. So you don't have to worry about bringing it down every time and all the parentheses and brackets. You have that common factor, you factor this polynomial elsewhere, you put them back together at the end. Okay, great job. Hang in there. All right, I'm looking at this polynomial right here, 6x squared plus 4x minus 21x minus 14, and I'm thinking, dude, we've got some like terms right here. Why don't we group these together, right? I think my initial gut reaction is to take this and write this as 6x squared minus 17x minus 14. But when I look at this polynomial, I'm like, okay, it's a trinomial. No common factors. We don't have a nice coefficient of 1 on our x squared. It's not a perfect square trinomial. We actually don't yet have the skills to factor this trinomial. So let's just put that off to the side for a moment, and we'll consider that a little bit later. So with that in mind, it appears that we are going to have to try to factor this using the grouping method that we've been talking about. So let's group the first two. So we've got a 6x squared plus 4x. We've got a negative 21x minus 14. All right, first grouping, common factor, I'm thinking 2x. So we've got 2x times the quantity of 3x plus 2. Second grouping, we could factor out a 7. I think would be even better is a negative 7. So minus 7 times the quantity of 3x plus 2. Awesome. I'm noticing that we've got a 3x plus 2 and another 3x plus 2, meaning our final factorization will be 2x minus 7 times the quantity of 3x plus 2. Groovy. Awesome, awesome, awesome. And it just goes to show that since we could factor this polynomial right here, it means that we could have also factored this polynomial that we left in the corner up here. Just so long as we knew that we needed to break up this negative 17x into 4x minus 21x. And that's actually going to be the topic of our very next lesson. And I want to look at this very last one for a moment. All right, it's in standard form. I'm not seeing any common factors. We've got 4 terms. Boom. Let's go ahead and try to factor this guy. All right, so that guy is going to factor. Well, let's do some grouping. So we've got an 8w to the third minus 10w squared. And then we've got plus the quantity of 12w plus 15. All right. First grouping looks like it's got a common factor of 2w to the second power. So let's go 2w to the second times 4w minus 5. And the second grouping looks like it has a common factor of 3. And so we got 3 times the quantity of 4w plus 5. Wait a second. I'm noticing that in this first part, we have 2w squared times 4w minus 5. But in the second part, we've got 3 times the quantity of 4w plus 5. Well, because these two polynomials in these sets of parentheses are not exactly the same, that means we cannot proceed. It appears that this polynomial right here is not factorable using this grouping strategy. So, like I said before, it works some of the time, but it does not work all of the time. So, in this case, yeah, that's it. We can't go any further. This guy is not factorable using the skills that we have right now. So, that's it for this lesson. I hope you found it helpful, and I hope you enjoyed.